In this video, we're going to talk about dividing polynomials with long division. There is another type of division that you might learn in a later lesson, but for long division, we're focusing on the same type of methods that we used with long division in like elementary school. When we have a division problem, let's write it out with regular long division that you've seen before. So maybe I have 7 into 1,852. The 7 is what's called our divisor. So that's what we're dividing by. This 1,852 is our dividend. And our answer is the quotient. So that's what we're trying to actually find, is the answer to a division problem. So when we did this, we said, let's take 7 into 18 first. And we were trying to divide 18 by 7. So how many times can 7 divide evenly into 18 would be 2. And then we started doing 2 times 7. So 2 times 7 was 14. Since we drew this line here, this is where we did subtraction. So I subtracted 18 minus 14. I got 4. We bring down the 5, and we start this all over again. So this is going to seem at least somewhat of the same mechanics when we do this with a polynomial. So look at what we have for A. 6x squared minus 26x plus 12 is being divided by x minus 4. So this is what we're dividing by. That's our divisor. We're going to put that outside of our division bar. And then what goes inside is our dividend. So that would be our 6x squared minus 26x plus 12. So each time we start the division process, when I did this over here, I started out with 18 only. We did 18 divided by 7, and we were looking for how many times can it evenly divide into 18. If I do that here, I like to do a little bit of scratch work off to the side. But I'm taking the first term and dividing by the first term of the divisor. I'm not going to worry about everything else. So I'm just using 6x squared and dividing by x. That's going to give me a 6x. So that is the first thing that I bring up top. So let's bring that up here, 6x. Just like I brought up the 2, that was the first part of our division answer that we got, and we took that 2 and multiplied back down to the divisor. So we're going to take that 6x and multiply down to the divisor. And it really does to go to every single term this time. So 6x times x is 6x squared. 6x times negative 4 is a negative 24x. Okay, so I try to make a big deal out of this with students, but every single time I draw a line here, I know that that's going to be our subtraction process. I do want to maybe use a different color in my subtraction, so I always just try to grab a red pen and make our subtraction, because we're subtracting the whole thing just like we subtracted the whole 14. I'm subtracting this right here. So I'm subtracting a 6x squared and subtracting a negative 24x. So when I do that line and make the subtraction, then I can work straight down. So here I did 18 minus 14, got the 4. We're going to subtract straight down. So 6x squared minus 6x squared is just 0, so that would cancel out. But when I do a negative 26 minus a negative 24, minus a negative is the same as plus a positive. So that changes that sign to plus there. But negative 26 plus 24 is a negative 2x. Bring down your 12, and we start the process all over again. So just like we brought down the 5 we would start this over again with 7 into 45. So how many times can 45 be divided evenly by 7? Would be 6. And you start that process again by doing 6 times 7 is 42. When we draw that line, that's where we subtract. So let's do this again. I start with the first term, so negative 2x. Negative 2x divided by our first term of the divisor is x. Negative 2x divided by x is negative 2. So that goes up top. That's part of the answer. And then we multiply all the way through. So negative 2 times x is negative 2x. Negative 2 times negative 4 is a positive 8. We draw this line, so every single time we draw this line, that's where we change our color and do subtraction. So I'm subtracting and subtracting. We subtract every piece of this. So if there's multiple pieces, do every single one of them. I see subtract a negative. Well, subtracting a negative is the same as plus a positive. That makes this 0. Negative 2 plus 2x is 0. 12 minus 8 is a positive 4. Oops. If I go to try this division process again, there won't be anything for me to do. 4 divided by x is not going to divide evenly. So think back how we did this. We did 3, brought down the 2. We started the process all over again. So 32 divided by 7 would be a 4. 4 times 7, 28. Subtract, and we get positive 4. Now what we did with that 4, that was called our remainder, and we learned about fractions, which made this 4/7. So our whole answer was 264 and 4/7. So you just take that divisor and put it, that remainder, and put it over the divisor. So this 4 is our remainder. And I just put plus 4 over x minus 4. That's the entire answer. So I'd write that out as 6x minus 2 plus 4 over x minus 4. Our quotient is the first part, 6x minus 2. The remainder is just 4. It's not the whole 4 over x minus 4 because that is the remainder over the divisor. Our remainder is just 4. Okay, so this is going to look weird the first couple of times that you do it. You may be completely lost at this point already, but hopefully you're seeing some similarities between this and the old school long division algorithm. So we want to know, how do we check ourselves? Well, we can rewrite this using the division algorithm and multiply it out. So what the division algorithm says, as I kind of skipped it in the very beginning here, is that if we have a polynomial p and d, there exists a unique polynomial q and r where r is our remainder. And so it follows this, that the polynomial is equal to our divisor times the quotient plus the remainder. All right, that doesn't make a whole lot of sense to us yet, but let's think about this with regular numbers. Let's say I have 5 into 85. 5 goes into 8 one time. 5 goes into 15 3 times. It has no remainder. So I know I could check it out, that 85 is equal to 5 times 13. And I could check that in my calculator, that's fine. If we had something that had a remainder, then we would just add the remainder on. Ours is plus 0. So let's do that with our regular number over here and check it out. 1852 should be 7 times 264 plus the remainder of 4. And it is 1852. So that's what the division algorithm is saying. We would take 6x squared minus 26x plus 12. That should equal our divisor, x minus 4, times the quotient, 6x minus 2, plus our remainder. Our remainder is just 4. And let's multiply that out to check it. X times 6x is 6x squared. X times negative 2 is negative 2x. 4 times 6 is negative 24x. And negative 4 times negative 2 is positive 8 plus a 4. Combine like terms, I get 6x squared, negative 26x, and 4 and 8 is 12. That does come out to be the exact same thing. We know that we've done it correctly. So there's a way for you to check your work. It does require a lot of steps because you're multiplying it back through, but that's one process in checking it. So let's try this all over again. We've got our division problem here. Our divisor is 4x plus 5. So I'm just going to write that out, 4x plus 5. And we're dividing it into 4x cubed minus 7x squared minus 11x plus 5. I take this and just do it off on the side. So I'm taking the first term, 4x cubed, and dividing by the first term of the divisor for 4x. So 4 divided by 4 is just 1, but x cubed divided by x is x squared. And that's the first part of our quotient. We can write it up top. Our quotient multiplies to the divisor, so x squared times 4x is 4x cubed. X squared times 5 would be 5x squared. And every time we draw this line, we're going to subtract. So make a big deal out of it to yourself so that you get that in your head. But negative 4x cubed is going to cancel with that positive 4x cubed. But a negative 7x squared and a negative 5x squared is negative 12x squared. Bring down our negative 11x, and we start the process all over again. So now I'm going to start with that negative 12x squared. That is being divided by 4x. That's a negative 3x. That goes up to the quotient, so negative 3x. And we multiply it back to the divisor, so negative 3x times 4 is a negative 12x squared. Negative 3x times 5 is a negative 15x. Every single time we draw this line, we subtract. So I just subtract. What we see is that we're subtracting a negative. So when we subtract a negative, what that does is change the sign to plus a positive. Negative 12x squared plus a 12x squared is 0, but negative 11 plus 15 is a 4x. And we bring down this plus 5 here. We can do this one more time, start it all over again. I got 4x here divided by 4x. I'm doing the first term divided by the first term. That's just 1, so plus 1. We multiply that all the way through, so 1 times 4x is 4x, 1 times 5 is 5. Draw that line. So when we draw that line, we subtract, and I've got subtract. Notice what happens is I get 0 as my remainder. So this is divided evenly into that polynomial. So this is our quotient. And our answer is just that quotient, x squared minus 3x plus 1. I don't need to put plus a remainder because there is no remainder here. So our quotient, x squared minus 3x plus 1. Our remainder is 0. Now you'll see some questions where it just says divide and it's wanting just the answer. Sometimes to make it easier for our test, we'll ask you to identify what the quotient is and what the remainder is separately. So if you're asked that way, you want to make sure you separate them, and the remainder is just that value. It's not the whole fraction here, so it's not that whole fraction. We put the remainder over the divisor when we're writing out our answer. All right, let's look at C. C is a little bit special. So if you have missing terms, all right, so if you have missing terms, fill them in with a 0. Okay, so 3x to the 4th. Then I keep looking down the line and notice there are missing terms. So if I have an x to the 4th, there should be an x cubed, an x squared, an x, and a constant term. We have some missing ones. So when we write out our division thing, we're dividing this by x squared minus x minus 3. So there's the divisor, x squared minus x minus 3. But I'm going to fill in our missing terms when I start writing out our dividend. So 3x to the 4th plus 0x cubed plus 0x squared minus 2x plus 1. Now, if you watch a different video or you look at a different book, they may not tell you to fill in these missing terms, but I've been teaching this for years, and I guarantee that's going to help you make less mistakes. Because what we'll also notice is as you're going through these, if you make one small error, if you forgot to subtract correctly, or if you just messed up like 11 minus 15, you just got like a 2 or something, that's going to screw up the rest of the answer, unfortunately. So you want to be kind of meticulous in your division. That's why I'm recommending that you just fill this in, and it will make your life a little bit easier. All right, so we do our first term divided by first term. 3x to the 4th divided by x squared. That's going to be a 3x squared. 3x squared times x squared is 3x to the 4th. 3x squared times negative x would be a negative 3x cubed. So this is why I fill in this in, because I needed a place to put my 3x cubed. So that's a negative 3x cubed. Then we have 3x squared times negative 3, so negative 9x squared. And I draw that line. So every single time we draw this line, we subtract. So we're going to subtract, subtract, subtract. And I see some minus and negatives, which is plus a positive. So that is 3x to the 4th minus 3x to the 4th is 0. 0 now plus 3x cubed is just 3x cubed. 0 plus 9x squared is 9x squared. And we can bring down the minus 2x. We start this process again. So 3x cubed divided by x squared is 3x. So I bring that up top. And we multiply it all the way through. So 3x times x squared is 3x cubed. 3x times negative x is negative 3x squared. 3x times negative 3 is negative 9x. We draw this line, so every single time we draw that line, we are subtracting. So I make a big point to subtract, subtract, subtract. That helps me realize that we're subtracting a negative, which is plus a positive. Subtracting a negative is plus a positive. We work our way down, so 3x cubed minus 3x cubed, a 9x squared plus 3x squared is 12x squared. Negative 2x plus 9 is plus 7x. And let's bring down the last part, so plus 1. We'll do this one more time. 12x squared divided by x squared is just 12. So plus 12 up here. We multiply it through. That's a 12x squared, a minus 12x, and a minus 36. Draw that line. There's our subtraction. So we subtract, subtract, subtract. I see some now minus a negative, so plus a positive, and minus a negative is plus a positive. Finishing this out, we get 12x squared minus 12x squared, 0. 7x minus a negative, so that became plus. 7x plus 12 is 19x. 1 plus 36 is 37. Notice if I try to do this any further, 19x divided by x squared is not going to come out even. So that's as far as we can go. This whole thing is our remainder. So it's possible that you have an expression and not just a number for the remainder. I can write that out, 19x plus 37. Our quotient was 3x squared plus 3x plus 12. But if we were writing this out as an actual answer, when we divide it, it would be 3x squared plus 3x plus 12 plus 19x plus 37 over x squared minus x minus 3. All right, so there's a lot going on in that problem. The last one is just written a different way, but it says we have a function f and a function g, and we want to find f divided by g. This is what we've done in the last module, this division of functions, but we now have a way that we're going to simplify it. So if we did do f divided by g, that would be 2x cubed minus 7x squared plus 5 over x minus 3. And turning this into our long division would say x minus 3 is our divisor. 2x cubed minus 7x squared. And if I start writing plus 5, I'm realizing there's no x value. So this is plus 0 x's and then plus 5. All right. So 2x cubed divided by x. Let's just do our scratch work off to the side here. Not everybody's going to recommend you do this, but I think it's helpful as you're first starting to learn it. That gives me 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. We draw that line. Every single time we draw that line, we're subtracting. So we'd have minus and minus. And so then that would give us a 2x cubed minus 2x cubed. Minus a negative is plus a positive. So a negative 7 plus 6 is a negative 1x squared. Bring down our 0x. We just write that out in our scratch work here. So that would be a negative 1x when we divide. Multiply that through is negative 1x squared. Negative x times negative 3 is a positive 3x. And we draw a line. Every single time we draw this line, we're subtracting. So we've got minus and minus. Minus a negative is plus a positive. That's 0. 0 minus 3x is negative 3x. Bring down the 5. So plus 5. Negative 3x divided by x would give me a negative 3. That's that last part there. We multiply it all the way through again, so negative 3 times x is negative 3x. Negative 3 times negative 3 is a positive 9. we draw that line, so I'm going to subtract and subtract. Minus a negative is plus a positive. We see negative 3 plus 3 is 0, but 5 minus 9 is negative 4. All right, there's our finished process. So our answer would say 2x squared minus x minus 3 plus a negative 4 over x minus 3. So that will work for me. You will see if you were to look this up on certain answer keys or whatnot, sometimes they'll take that and just write this as 2x squared minus x minus 3. And instead of putting a plus, they've taken that minus sign and put it down here and done minus 4 over x minus 3. That's also equivalent. So either way is fine, but I just want to make sure that you're at least starting out writing it in the proper notation. So try these out. It's going to take some process and some practice for you to really get the hang of it, but this is the long division process.